Welcome again to Introduction to Programming using C++. My name is Murugesh, and today I'm going to take you to Unit 2, some concepts in Unit 2. The first one will be operators. As you might have come across, there are classification of operators like arithmetic operators, relational operators, logical operators, etc. So today's session we will discuss about these operators using some of the C++ example programs. Arithmetic operators. Basically, what is the need of the operators? Sometimes you might need to perform addition of two numbers. Okay. Like 5 plus 7 equals to 12. So here we use two operations. One is the plus symbol, other one is the equal to symbol. So these are all the operators. This is addition operator and this is equal to operator. So in this expression we used two operators. Fine. So addition, the arithmetic operators, you have 5 arithmetic operators: plus, minus, multiplication, division, modulo. Multiplication, usually traditional multiplication is you put a cross, but in programming we don't have this. This is x, but if you want to do an arithmetic operators, use asterisk. This is asterisk, and this is a division. The backslash is a division operator, and this one is called as modulo operator. So for example, mm, 15 divided by 5 equals to 3, isn't it? So here I have used division operator. This is division operator and the equals to operator. Say the modulo operator. 15 divided by 2 is what? Sorry, modulo operator. Modulo is what? The percentage. Percentage symbol is called as modulo operator. So why you need this modulo operator? The modulo operator is used whenever you need to have the remainder of a division operation. You use modulo operator. So this will give you what? Not the quotient but the remainder. The remainder is what? 1. 15 divided by 2 will give you 7, and 15 modulo by 2 will give you 1. Okay, I hope you understood. Let's see how are we going to use it in our C++ programs. I've created a program called as add CPP. This is, I hope you understand the first two lines. These two lines are nothing but the header files which has to be included for some functions, like say you wanted to iostream.h include hash include iostream.h is used for input output statements like cout, cin are the cout is the standard output statement in C++, and if you want to use it in your program, obviously you will use it in all the programs, then you need to include iostream.h header file in your program for it to understand that this cout statement is a predefined function that is found in iostream.h, and you import the iostream.h package, the header file, into the current program, and you can start using all the functions which are predefined or already declared in that header file in the current program. Like that, getch is another function which I have used it in this program, and that function is declared in conio console.io.h input header file. As like CLR the clear screen function is also a conio.header file. It is from conio.header. Conio is nothing but console input output io. All right, let's go into the main method of the C++ program. In the main method, I have declared three integer variables, a, b, and c, and the first two statements are for inputting the first number. The second, the highlighted two statements are for inputting the second number, and this is the statement for you to compute the addition operation, c equal to a plus b, where c is I assumed that c is, let c be my output variable, a and b be the input variable, and finally after calculating the result and storing it in the C, I can print the result that is stored in C variable in the highlighted statement. Fine. So let's see what is the result. You compile the program, press Alt F9 to compile, and press Ctrl F9 to run the program, execute the program. So now you enter the first number, you enter the second number, you get the result, which is 88. Okay, let's try and give some complex numbers. So it is enough to compile once, then after that step you can start executing the program again and again and start giving different inputs. Say this time I wanted to give 56 like this. Okay, let us see. I give a negative number 34. I give another positive number 89, and the result is you get 55. So I hope you understood the addition of two numbers. Okay, similarly, so now we have covered the second topic, which is arithmetic operators. The third topic is the relational operators. What are the relational operators? Let's see the relational operators. Relational operators are the operators, like usually when you have a internet and you wanted to verify any concept, you can go step into this c++.com, which is the internet website for your own reference. You can see all the all the concepts which are clearly explained here in this site. So we have already covered this one. Now, relational and comparison operators, as you can see here, the highlighted one, these are the relational operator. The double equal to is the equality operator. This is the not equal to operator. This is the greater than. This is the less than operator. This is greater than or equal to. This is less than or equal to operator. Alright, so the examples are here. So what this does, 7 double equal to 5 evaluates to false because 7 is not equivalent to 5. When it will be true? Say for example you wanted to evaluate 5 equal to 5, then this statement will give you a true. Okay, basically all these relational operators will be evaluated to either true or false. Okay, so let's take an example. 5 greater than 10, which will evaluate to false because 5 is not greater than 10, 5 is less than 10. Say 6 less than 3. 6 is not less than 3, it is greater than 3, so it again evaluates to false. Okay, same 6 greater than 3 will give you a true value because 6 is greater than 3. Okay, here I have used the numbers, directly the numbers, but once you have stored all these numbers in variables, you can use a, substitute the variables here. Instead of 5 you are substitute a, and instead of 10 you substitute b. For instance, you can have any valid variable names here. Okay, so once you use variables, what it happens is your program is more dynamic. How dynamic? Because once you started to use variables and you input the variables when you run the program, what happens is each time you run the program, you give different inputs so that the program produces different outputs. So that's why I said it becomes more dynamic once you started to use variables. I hope you get the concept. So you can use variables. You can see here the first example they have used numbers directly. The second example they have used the variables. A is a variable. You can input a, any valid number, and then start evaluating in that expression. Okay, so remember, less than, this is less than, this is greater than, and okay, let's go to the editor. Double equal to is equality operator, greater than, less than, greater than, equal to, less than, equal to, not equal to. These are the available relational operators, or it can be also called as comparison operators. I hope you have got it. The next topic will be the logical operators. What are logical operators? So logical operators are, you have three logical operators. And, or, and not. This is called as logical and. This is two pipeline symbol. Pipeline symbol, you can find it in your keyboard, which is just above the shift key. Okay, shift key, just above the key which is combined is the division key and the pipeline key. So when you have two pipeline symbol, it is called as logical OR, and when you have the exclamation symbol, it is called as not operator. Okay, right. How to use it, when to use it? Say for example, usually when I teach my students to make them understand, I create truth tables for logical and, or, and not. What is a truth table? Let me explain. That will be easier for you to understand. The truth table for and, x, y, and, okay, sorry, and, which is nothing but double ampersand, or, which is nothing but the pipeline symbol. Okay, let's create the table. 0 and 0, 0 and 1, 1 and 0, 1 and 1. 0 stands for false, 1 stands for true. I hope you must have come across this one in your mathematics class. So false and false is again false, or false and or false is again false. Okay, let us go vertically down. And false and true is again false. True and false is again false. True and true is true, because for an AND operator to give you true, both the expressions has to evaluate to true. Say for example, I will give you an example for this and make you understand. In this case, the or logical operator, for 0 and 0, the false and false give you false. If either one of the operand is true, then for that the logical OR evaluates to true. So for all these values you will get true, because either one of your operands here is true, so OR does not mind about the other operand and it evaluates to true. Let's give you an example of this. Fine. Say you have 5 equals to 6, or 7 greater than 2. What does this gives you? Okay, so 5 equals to 6 will give you what? Is 5 equals to 6? Logically, is it equivalent to 6? No, it is not equal, so it will evaluate to false. 7 is greater than 2. Yes, it is greater than 2, so it evaluates to true. So the operation result of the whole expression, you will get what? True is the result. The same thing. Let's put it the other way. 5 equals to 6 and 7 greater than 2. Alright, this will give you what? 7 is greater than 2. Yes, it is greater, so it is true. 5 is equal to 6. No, it is not equal, so it is false. So the result of this will give you what? True or false? What it will give you, because here you have a logical and it will give you what? False. Why false? Let's go to the table. The AND operator. If you want to have a true result in an AND operation, both the operands, the operand X and operand Y, has to evaluate to true. One is true. Remember, one is true. Okay. In this case, here is a logical AND operation, and this is false, and this alone evaluates to true. Though it evaluates to true, the result of the other operand here, you can assume that this is the X operation and this is the Y operator as per the truth table. Okay. Once you have two operands, X is the first operand, X is the first operand, Y is the second operand. So the result of this operation will be, you have to substitute, in all the cases you need to substitute this important truth table for your operations and OR operations. Right. So the last one is the NOT operator. NOT operator is very simple. Say you have 7 greater than 2. You use like this. What is the result? 7 is greater than 2. Yes, it is greater than 2. So it has to evaluate to true, because there you have a NOT operator. What will be your result is, it will evaluate to false, because you have a NOT operator before the expression. You see here there is a NOT. The exclamation is what? NOT operator. Alright. So now we have come to the end of the session. I wanted to give you an exercise, a simple, very simple exercise for you to practice. You start creating a program in C++ using your C++ editor, and do arithmetic, subtraction, multiplication, division and remainder of the division operation using two numbers. Input two numbers and do this exercise and upload it to your Blackboard, and from there we can discuss. Thank you very much. Have a nice day.